Today's topic is radical algebra. Such questions are asked in SSC, CCL, Bank PO, Civil Service Aptitude Test, Railways exam, and various other state PCS exam. Let's begin. Category. We have two categories: addition and subtraction. In addition and subtraction, we have type 1, number reducible to consecutive factor. Suppose this is a number 6. We can have factor like 2 and 3. These two are consecutive, right? 2 difference 3 is equal to 1. They are next to each other. Consecutive means next to each other. And in type 2, prime number or number not reducible to consecutive factors. 7. We don't have any factor. And there are consecutive factors for 7. We have only 7 and 1. These two are not next to each other, right? And another example, this is not prime, this is prime. But we have 3 by 3. These are not consecutive, same factor, right? So such number are not reducible to consecutive factors. We have different method for this, we have different method for this. And in number 3, plus minus plus, or it may start with minus plus minus. We have different method for this. Category 2, multiplication. In multiplication, first category is infinite series of same base infinite series. One is for square root and another is for any root. Square root means this. Here if it is blank, we consider it as 2, right? This is square root, this is square root, right? Here suppose this is infinite series of square root. And nth root means instead of 2 we can have here any number, 3, 4. Let's suppose p, a. Here the root is p, infinite. For this we have different method, for this we have different method. Type number 5 is infinite series again of different base reducible to same base. Here the base is same, right? A. The base is the same, but here base are different, but one of the base is reducible to the other one. Example, let's say here 3 cube, here 9, again 3 cube, again 9, dot infinity. Here this is 3, we can express 9 as 3 square, right? Again 3 cube, then again 3 square, so base is same. In this also we will get the answer as the number itself, 3. Next, number 6. In type 4 and type 5, infinite series. But here in type number 6 we will find finite series. Example, 3 root 3. In infinite series we have dot. Here only 3 terms, or it may be n terms. 3 up to n, not infinite. Okay, for this we have different method. We will see this in today's class. Number 7, finite series of higher order. Here we have done in type 6 we have done of square root. Here this is 2, right? This is square root, right? Instead of this square root we can have any other. We may have 3, 4, 5, 6. Let's say p root of a, again p root of a, again p root of a. 1, 2, 3. This is finite, right? N equal to 3. Here n is number of terms. So let's begin the class. First one is type 1, number reducible to consecutive factors. Here see, number reducible to consecutive factors. We have 2. One is for here all plus. Here it is addition. For other one is negative, difference. For this, in this method we have to find 2 factor for a. Here we have the a, right? Base is a. For base a we have to find 2 factors such that just the factor 1. Suppose this is factor 1, this is factor 2. These two should be consecutive. These two should be consecutive. Means f1 difference f2 it should be 1. Their difference should be 1. That is consecutive. Difference should be 1. say now let's say f1 is greater than f2. If f1 is greater than 2 and the sign here is positive, then the answer would be f1, and here it is negative, right? The smaller number f2 would be the answer. See, here the sign is positive, so the larger factor f1 is greater, so f1 is larger, so f1 is the answer here. Here in this case it is negative, a minus a root over a, here all minus, right? So the smaller factor, which one is smaller here? f2, so f2 will be the answer of this root. Let's see some examples. Here 6, right? Here the number 6 can be broken down into 2 and 3. These 2 and 3 are consecutive because 2 difference 3 is 1. So, and again here it is positive, so the answer would be 3. 3 is the answer here. And here in this case it is negative, so it is broken down into 2 and 3. The smaller one is 2, so the answer is 2 here. Right, it's very easy, right? Let's see another example. 2 can be broken down into 2 and 1. 2 difference 1 is 1. So, and here it is positive, so the answer is 2. In this case 2 and 1, the smaller one, here it is negative, so the smaller one is 1, so 1 is the answer. 72, 8 9s are 72, right? So here it is positive, 9 would be the answer. What about this? It is negative, right? 8 9s are 72, so here 8 is the answer. Let's see some more examples. 12, 3 into 4. These are consecutive, right? And positive, so 4 is the answer. Here 3 into 4, negative, so smaller one, 3. 3 is the answer. 20 can be broken down into 2 consecutive factors, 4 and 5. 4 5s are 20, right? And 4 difference 5 is 1. So positive, positive, positive. So 5 is the answer. Here 4 5s are 20, negative, negative, negative. So 4 is the answer. 9 and 10. 9 difference 10. 9 difference 10 is 1. So, and here it is all positive. So 10 is the answer. Here negative. So 9 is the answer. Let's go to type 2. Prime number not reducible to consecutive factor. Prime. If any given n is a prime, then it would have only 2 factors. The number itself n and 1. And their difference cannot be 1. It cannot be 1. And if n is not a prime and has no consecutive factor, 9 we don't have consecutive factors, right? These two are same numbers, they are not consecutive. So in this case what we do is we either follow direct formula, say prime number 7 plus root 7 dot up to infinity. Okay, so this is a prime number, so we cannot have 2 consecutive factor. Here n, this is a, so direct formula is 4 into 7 plus 1. This here it will be plus or minus 1. If this is plus, then we will choose plus. If this is minus, we will take it as minus. All divided by 2. This thing remains the same. Under root is the same. 4a plus 1 always. The difference is here either plus or minus 1 by 2. Okay, let's see. We either follow this direct formula or left or right procedure based on this sign. If it is positive, we will follow right, and if it is negative, we will follow left. It is left, L-E-F-T, not left, L-E-F-T. L-E-F-T, left. Left and number line we know, right? Left and right. That's what we mean by left and right. Change this to E, left. Here what will we do? Right procedure. Here we'll go on a number line system, we'll go towards right, and here we will go towards left. It is negative. See? Here positive, so the number line is here. We have seen the number line drawn. And given number is A. So we will go towards the right side. What we have to find is the, here it is A. A plus 1 will be another number. A plus 2 will be here. A plus 3, A plus 4. We have to find a number nearest to A which has consecutive factor. Which have consecutive factor F1, F2. Consecutive factor. Find the nearest greater number. Find the nearest greater number than A. A number bigger than A which is nearest to it. The next number bigger to A that has consecutive factors. We have to find it. Then solution lies between these two consecutive. Example, A is the number here. AR is the number that has two consecutive factor F1 and F2. Then the value of this solution, its value, let's say X. Then F1 less than X less than F2. This would be the solution. What about negative? In negative case, let me rub this. In negative case, the number line system, it will come towards the left. A number less than A. And we have to find a number less than A which has two consecutive factors. Suppose here it is A, and suppose here we have AL towards the left side, A minus 1, A minus 2, A minus 3. Here we find AL. It must have two factor F1 and F2 such that F1 difference F2 is 1. So the answer will lie between F1 and F2. Got it? And we, in such case, for prime number or number not reducible to consecutive factor, we have two methods, left or right, or this direct formula. We will use direct formula if the answer is given specific answer. If it is given in the range, suppose here F1 less than X less than F2. If the options are given in such way, in range, then we will follow this left and right, left or right method. If the answer is given as specific, like specific some value, then we will use this direct formula. 4A plus 1 plus minus 1. Plus is for this one, minus is for this one. If the series is with my negative sign, then we will use negative 1. If it is with positive sign, then we will use plus 1. Let's see some examples. Here root 3 up to infinity. Right here we have positive numbers, so what we will follow, and the options are given in range, so we will follow left or right. So it is positive, so we will follow right side. We will go towards the right in number line. Here the given number is 3, so we will go towards the right. Number next to 3 is 4. 4 has no consecutive factors. 5, it has no consecutive factor. Next 6. Do we have a consecutive factor of 6? Yes, two consecutive factors, 2 and 3. So the answer lies between 2 and 3. 2 is 2 2 is less than x less than 3. This would be the answer. Answer is B. Let's see for negative. X equal to, oh no, positive only. Option here is given some specific value. So we will use direct method, direct formula method. 4a plus 1 plus minus 1 by 2. This is the formula. Here it is plus, so we will choose plus 1. A is 3 here. Sign is positive. See, sign is positive. So we will use here plus 1. 4 into 3 plus 1 by 2. Root 13 plus 1. So the answer is C here. Let's see some more examples. Which here do we use direct formula or left or right? Left method. Here negative, right? So left. We'll go towards left in number line. What about this? Same question. Specific numbers are given as options. So we will use direct formula in this case. Let's see this one first. Here number is 1. When we go towards left, the next number is 0. So 0 has two factors, 0 and 1. Okay, 0 difference 1 is 1, which fulfills. So the number answer X lies between 0 and 1. Is there any option 0 less than X less than 1? So C is the answer here. What about this? Options are given specific value, so we cannot use the left right method, so we will use direct formula. 4 into 1 plus 1 root over under root over, right? And it is negative, so we will use minus 1 divided by 2. This is nothing but root 5 minus 1 by 2. Root 5 minus 1 by 2. D is the answer. Here let's see. This is positive, positive, positive. So we will root right methods. 5, next number is 6, 2 and 3. So X lies between 2 and 3. Or we can use direct formula. 4 into 5 plus 1. Here plus or minus. Here it is plus. So here it will be plus 1 divided by 2. This is nothing but root 21 plus 1 by 2. This is the answer. Either this or this is the answer. If the option is given in range, choose this. If it is given in specific value, choose this. Next question. Here it is negative. Negative, right? So 5. Next number is left, towards left is 4. 4 again 3 and again 2. 2 we have factors, consecutive factors. So the answer lies between 1 less than X less than 2. Answer lies between 1 and 2. This is one answer. Or we can use the direct formula. Root over 4 into 5 plus 1. Here it is negative, so it will be minus 1 divided by 2. This is nothing but root over 21 minus 1 by 2. Either this is the answer or this is the answer based on the options. Let's see some more examples. Okay, here Here we reduce this to 2 consecutive factor. No, right? So it is positive. So we will go to what's right. Next number is 10. No consecutive factor. 11. No consecutive factor. 12. 12 we have consecutive factor 3 and 4. So the answer lies between 3 less than x less than 4. In some option they may give this also. Okay. Or they may only give this. 3 less than x less than 4. Let's check by direct method. 4 into 9 plus 1 root over plus 1, since this is positive, divided by 2. Okay, this is nothing but root 37. 4 9 is 36 plus 1, it is root 37 plus 1 by 2. When you find the value of this, it will lie between this 3 and 4. Again here 9. 9 means it is negative, right? Negative, so we will go to what's left. 9, 8, then 7, then 6. Yes, in 6 we have 2 and 3 consecutive factor. So answer lies between 2 less than x less than 3. This is the answer. Or if the option is given in specific value, let's check. Root 4 into 9 plus 1. This is fixed. Here it will be minus or plus. Here it is negative, so it will be minus 1 divided by 2. So what is this? Root 37 minus 1 by 2. This is the answer. For negative and positive, answer will be here. The difference will be here. It is plus 1. Here it will be minus 1. The rest, root 37 by 2 remains the same. Let's see some more examples of, let's see root 7 and 1 is positive, 1 is negative. So it is 7. 7 next is 8. Next is 9. Next is 10. We don't have consecutive factor. 11 we don't have consecutive factor. 12 we have 3 and 4. So what will be the answer? 3 less than x less than 4. This is the answer. Or if the option is not given in range, then formula. Root 4 into 7 plus 1. Here it is positive, so it will be plus 1 divided by 2. Right. This is 4 7 is 28 plus 1. So root over 29 plus 1 by 2. Let's see here. 7. 7 previous number is 6. So 2 into 3. Answer lies between 2 less than x less than 3. This is the answer. Or if the option is not in range, then 4 into 7 plus 1. This would be under root minus 1 divided by 2. It would be root 29 minus 1 by 2. When you solve this, you will get the answer between this only. Let's check the last example here. 11. Next number is 12. 3 and 4. So answer lies between 3 less than x less than 4. This is the answer. By formula for 11 plus 1, this would be under root plus 1 divided by 2. So root 45. 4 11 44 plus 1 45, right? Plus 1 by 2. Here 11 will go by 10. No consecutive factor. 9 no consecutive factor. 8 no consecutive factor. 7 no consecutive factor. 6 we have 2 and 3. So answer lies between 2 less than x less than 3. This is the answer. Or root over 4 into 11 plus 1. Here will be minus because it is minus here. It will be minus 1 by 2. The answer would be root 45 minus 1 by 2. Done. So next, let's go to next type. Type number 3. Type number 3 is alternate plus minus plus minus. Let's see here. Alternate plus minus series or minus plus series. It may be start with minus plus or it may start with minus. If start with plus, we have different formula, and if start with minus, we have different formula. General formula is this. Here for plus it will be plus, for minus it will be minus 1. Root 3 minus under root 4a minus 3. This remains the same for all, either plus or minus. The only difference is in plus 1 or minus 1 divided by 2. This remains the same. 4a minus 3 under root 4a minus 3. This remains the same. Only difference is here. If the series start with plus, then plus 1. If the series start with negative, then negative 1. Okay. Case 1, plus starting with plus. Case 2, starting with negative. Negative minus plus minus plus. Here it is plus minus plus minus series. Let's see. X equal to root a plus, again here it is minus, again plus minus up to infinity. In this case, minus plus minus plus. So the formula is root a minus 3 plus 1 here. In this case it will be minus 1. So remember this formula. In the previous formula we have, let's recall the formula, 4a minus 1 under root plus 1 it is in the previous one, plus minus 1 by 2. Here in this case it is 4a minus 3 plus minus 1 by 2. So remember these two formula. This is for alternate series. This is for if it is plus 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 series or minus 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 series. Here it is plus minus plus or minus plus minus. Here minus 3. Here it is plus 1 under the root. Difference. Let's see some examples. Okay, here is 4. So a is equal to 4, right? So the formula is 4a minus 3. Here it start with plus, so it will be plus 1 divided by 2. This is 4 into 4. Yeah, a is 4, right? 4 into 4 minus 3 plus 1 by 2. So 16 minus 3 is root 13. Here it is 16 minus 3 root 13 ho gaya. Then plus 1 by 2. This is the answer. Here let's see here. 4a minus 3. Since this is negative, so it will be negative 1 by 2. 4 into 4 minus 3 minus 1 by 2. Answer would be root 13 minus 1 by 2. Let's see one more example. Plus minus plus. Here it start with plus. Here it is minus plus minus. So it start with minus. Here it start with plus. So the formula would be root over 4a minus 3 plus 1 by 2. Here it would be 4a minus 3. This would be under root minus 1 divided by 2. This is nothing but 4 into 2 minus 3. This would be under root plus 1 divided by 2. 4 to is 8. 8 minus 3 is Root 5 plus 1 by 2 is the answer. Here it will be 4 into 2 minus 3 minus 1 by 2 equal to root over 5 minus 1 by 2. Category 2, we have come to multiplication. Infinite series of same base. Base means this, right? Same. If the base is same, then the answer is the base itself. A, right? A is the base here, and it's up to infinity. It ups to infinity. This is not finite, infinite. Infinite series, if base is same, then the answer is the base itself, A. Let's see example. We can understand easily through examples. Here 2 2 2 up to infinity, right? Dot 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 up to infinities, so the answer is 2 here. Here 7 7 7, so the answer is 7 here. Let's see some more example. Here this is the base, 3a plus 1, again under root 3a plus 1, 3a plus 1 up to infinity, so the answer is 3a plus 1 itself. Okay, here it is 13 13 13 up to infinity, so 13 is the answer. This is very easy one. Let's go to type 4 special case. Here infinite series but not square root. In the previous one it was a square root, but here it is not square root, but it is nth root. Nth root means this is a square root, here it is 2, is equal to this, right? But here it is nth or any other number, p, 3, third root or fourth root or fifth root. Then how we solve this? Let's check. Here see n, and the base is same base, but this root is not square. It's not square root, it is nth root. It may be 3 4 5 6, any number. It may be 50 also. So keep the number x, the base will the base would be same. The only difference is the power. 1 by, we know the notation, right? This means this is equal to x to the power 1 by n, and x equal to x to the power 1 by 2. If it is here n, then it is 1 by n. If it is 2, 1 by 2. So in such case the answer would be x raised to the power 1 by n minus 1. Do minus 1 from the nth root n. If it is 3 here, then 1 by 3 minus 1 x. This is 1 by 2, x to the power 1 by 2. If it is 4, if it is 5, x 5 x root fifth root of x dot dot dot, then x would be 1 by 4. 5 minus 1 is 4, 1 by 4. Let's see some examples. Here it is 4, so keep it is as 4. Keep it is as 4. 1 divided by 3 minus 1. It is 3, right? Here we have 3. Third root, so 3 minus 2. So the answer would be 4 to the power half. This is nothing but this is equal to this, right? Equal to 2. Answer is 2 here. What about here? 7 to the power 1 by, here it is 5. 5 minus 1 equal to 7 to the power 1 by 4. Now let's check for different infinite series, different base reducible to same base. In the previous one we have the same base, x. Here it may be x, a, b, x, y. Let's see. the base will not be same here. See, here the base is A, here the base is B, here A again, here B again, A alternate A B up to infinity. If B is reducible to, it is saying it's reducible to same base, right? We have to reduce this B to A. If B is equal to A to the power n minus 1, example 3 cubed, and here it is B, 3 cubed, here it is 9. This is A, this is B, this is B, this is B. So B here 9 can be reduced to 3 square. This is what it means. Here it is power 3, right? Here is power 2. 2 is nothing but 3 minus 1, that is n minus 1, right? So in this case also the answer would be the number A itself. If we can reduce this, let's see here. See, it's reduced. A to power n, here B is reduced to A to the power n minus 1. A to power n minus 1, A to power n minus 1. Alternate power, same base, alternate power. If reducible to same base, then the answer is A. Let us see example. It will be easy through examples. Here, let's see both the question, then we will solve. Okay. Here it is 3 cube. Here it is, I think I have done this in the previous slide. 3 square. We can reduce this as 3 square, right? So we can write like this: 3 cube, 3 square, 3 cube, 3 square, dot dot dot. This is A, this is A n minus 1, right? So the base is 3, so answer is 3. Here also see 2 cube, 2 can, this 4 can be reduced to 2 square, right? 2 square, 2 cube, 2 square, same base, so answer is 2. Here 2 is this 1. What about this here? 3, right? 3 to the power 1. Let's go to type 6, finite series of second root, square root. Finite series means up to now we have been doing dot 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 up to infinity, right? Instead of infinity we will have n, number of terms, countable number of terms. Let's see. A up to what time? N times. So the number of terms will be n. Here number of terms, n equal to number of terms. So in this way, in this case, we will keep this base as A raised to the power. What is here? What root it is? Second square root, right? So square root means we will consider 2 is there. This is nothing but this, right? So if it is empty, it is 2. So 2 raised to the power, count the number n, number of times n, up to n minus 1. 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 3 dot 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 up to, it is that if it is the number of times n, then the power should go up to n minus 1. One number less than n. One number, 1 less than n. And denominator should be this root 2 to the power n, not the number of terms here, n the number of terms, okay. In this way we can solve, or we can solve by using direct formula here. A raised to the power 1 minus 1 by 2 to the power n, here denominator. If it is square root, take 2. 1 minus, if it is square root means is 2, right? 2 to the power number of terms here. Or we can do this. 2 to the power n minus 1 by 2 to the power n. This and this same, right? When you take LCM, you will get this. If you take LCM 2 to the power n minus 1 whole divided by 2 to the power n, these two are the same. Example. Through example, you will understand. Here, see how many terms? 1, 2, 3, 4. N equal to 4. So this implies x equal to a. Here base is a, so it is a over 1 minus 1 by 2 to the power 4. Here it is, the number of term is 4, right? So 2 raised to the power 4. Or we can write like this: 2 to the power 4, 2 to the power 4 minus 1 by 2. If you take LCM, you will arrive here. This is easy, right? Let's do some example, then you will understand easily. Let's do these two examples. Okay. Count the number of terms here. 1, 2 and 3. 3 terms, right? N equal to 3 here. So let's go by traditional method. 5, give 5. Here what is this? Square root, right? So 2 raised to the power 0 plus 2 raised to the power 1. Here 3, right? Up to 2 we have to go. 2 raised to the power 2. That is 2 square. Divided by 2. How many terms? 3. So it will be 3. 5 raised to the power whole thing. This is nothing but, here is 4, 5, 6 and 1, 7. 7 by 8. 5 raised to the power 7 by 8. So it is the B. Or we can directly 5 raised to the power 1 by 1 minus 1 by 2 to the power 3. This is 5 raised to the power 2 cube minus 1 by 2 cube equal to 5 raised to the power 7 by 8. Right? Either you can do this or you can go for this. Let's see this. How many terms? 1, 2, 3, 4 and 5. So 2 raised to the power 0 plus 2 raised to the power 1 plus 2 square plus 2 cube plus 2 to the power 4 up to 4. You have to count up to 4. Whole divided by 2 raised to the power 5. This will be raised to the power 2, right? And you will get the answer as 2 raised to the power 31 by 32. Let's check by formula. Here it is 2. Here it is, sorry. This is 1, 2, 4, 8, 16. 20, 28, 30. 16. This is 20, 28, 30, 31. And 2 raised to the power 5 is 32. 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5. It is 32. 4, 4, 16. 16 to the 32, right? So it is 32 down. Let's take it 2 by 1 minus 1 by 2 to the power 5 equal to 2 raised to the power 32 minus 1 by 32 equal to 2 raised to the power 31 by 32. 2 raised to the power 32 by 31 by 32, it is C. Answer is C. Same type of question but higher order. Here it is square root, right? So the next step would be higher order, not 2. It may be 3, 4, 5 or n. Here instead of second root, here it will be 3, 4, 5. Let's see. Finite series of higher order. See, here is p is greater than 2. For all p greater than 2, we have this. Same, the traditional method is the same. This going by power p0, p to the power 0 plus p to the power 1, p to the power 2 up to p to the power minus n. This remains the same. This method remains the same. The only difference is in the direct formula. See here, direct formula p to the power n minus 1 by p to the power n into this is extra. If it is here the root is pth root, then it will be multiplied by p minus 1. This is the extra term. This will multiply here. This is the extra. If it is 4, if this is 4, it will be 4 minus 1. If this is 5, this will be 5 minus 1. Okay. See, these two are same. 1 minus 1 by p to the power n into this is the extra 1 by p minus 1. What about p here? 1 less than p. You have to multiply with one number less than p. Example, let's see here 1, 2, 3, 4. Pth root. Number of term is 4. So x raised to the power, this traditional method remains the same. Difference is in the formula. 1 minus 1 by p to the power 4 into this extra. This term is the extra term. Remember this. In the previous formula we have this, right? In the previous formula we had this 1 minus 1 by 2 to the power n, because it was in square root, it is 2, so it will be 2. This was the formula, but here instead of square root it is p. So a raised to the power 1 minus 1 by, instead of 2 it will be p, right? Here it is 2. This means square root. Square root means 2 here, right? So it is 2. N raised to the power 2. 2 raised to the power n. Here it is p. P raised to the power n. N times. Then 1 by p minus 1. This factor is extra. A multiplication factor. A multiplication factor. Let's understand these two examples. And if you find this formula confusing, then you can go by this method. It's same for square root as well as any root. Either it is a square root or it is third root, cube root or it is fourth root. This method remains the same. Let's see some examples. Okay, here count the number 1, 2, 3, 4. Here n equal to 4. So keep 7. 1 minus 1 by what would be here? This number, it is 3, right? It is cube root, so 3 raised to the power, how many terms? 1 2 3 4, so 3 raised to the power 4, this one, into what is the root? Nth root, third root, right? 3 minus 1, this is the only extra, equal to 7 raised to 3 to the power 4 means 81. 81 minus 1 by 81 into 1 by 2. Here it will be 80. So 80 divided by 2 means it will be 40. So 7 raised to the power 40 by 81. Answer is 7 raised to the power 40 by 81. This is the answer. And suppose if you go by traditional method, let's check. Instead of using power, if you go by traditional method, let's see. Here it is 7. 7 base will be same. What is the third? Here it is 3, right? Cube root, right? So 3 to the power 0 plus 3 to the power 1 plus 3 square plus 3 cube. Why cube here? It is 4. 1 less than, in the formula we have n minus 1, right? So here the number of term is 4. So in the numerator the power will go up to 4. 1 less than the number of terms. And in the denominator the power would be the total number of terms, that is 4. 3 raised to the power 4. This one. 7 raised to the power 1, 3 raised to the power 0 means 1 plus 3 plus 9 plus 27 divided by 3 raised to the power 4 means 81. See, 27, 30, 39, 40 equal to 7 raised to the power 40 by 81. This one, D. Let's see this one. 1, 2, 3. 3 terms. N equal to 3. Base is 2, so keep it is 2. 1 minus 1 by, here it is 4, right? The root is 4. 4 raised to the power 3, that is 4 cube. Into what would be the extra term? It would be 4 minus 1. Right? This is correct, right? 4 cube means 64. 4 cube means 64. 64 minus 1 means 63. 63 by 64 into 1 by 3. Here 4 minus 1 is 1 by 3, right? And this base is 2. This can be cut. 3 2s are 6. 3 1s are 3. So 2 raised to the power 21 by 64 is the answer. Answer is A. Or we can go by traditional method. Let's check by traditional method. Base is 2. What is the root? 4th root, right? 4 to the power 0 plus 4 to the power 1, 4 square up to square. Here is number of term is 3. So 1 less than 3 is 2. So 4 raised to the power 2 divided by 4 cube. Okay, so here 4 to the power 0 means 1, 4 plus 4 square means 16, divided by 4 cube means 64, equal to 16, 20, 21. 2 raised to the power 21 by 64. Same, right? Same answer we get. So practice question. Do this practice question yourself. Okay, let me do this one. Here, what is this? This is infinite series of same base, infinite series square right here. So it will be base is just 1 by 2 minus 1 equal to, this is nothing but 7 cube. 7 into 7, 49 into 7 is 343. And here y minus 1. We have to find y. If the base is same, power would be same, right? 2 minus 1 is 1. So 3y minus 1 equal to 3y minus 1. 3y minus 3. Go. 3 into minus 1. This would be. Okay. 3y minus 3 equal to 4. This implies y equal to 4 by 3 is the answer. The rest of this you can solve. Easy one. Here it is 0 less than, and suppose this is y less than 1. Okay. Here it is 2 3s are 6. 2 is the answer. 56. Okay, you can do this. 90, we have done this already. 2. Here it is 2 answer. It is multiplication, right? Series 2. 8 8 8 8. Oh no, this is not 2. This is not 2. This is formula. A number of terms. Count the number of terms. 1 2 3 4 5. So use the finite formula. Here 2 1 minus 1 by 2 to the power 5, and then you can solve. We have done that already, right? Okay, do this yourself, practice, and practice this also. Okay, I'll do this 3. This formula, remember always. Any root, it may be 2 3 4 5. You will follow this only. Here what is this? 9 into 10. It is negative, so answer is 9 here. What about here? 3 and 2 plus, so 3 is the answer. 9 divided by 3, 3 is the answer of this. Y equal to 3. Here y equal to 3. This is the application of this formula. This formula, see, n3. Here n is equal to 3. This is nothing but 2 square inside, and to the power 3 minus 1. Here it is 3, right? This formula. And what is on the left side? 32, right? 32 means 2 raised to the power 5 is 32. Check 3, 2 into 2 into 2 into 2 into 2. 1 2 3 4 5, right? 4 4 16. 16 to the 32. And here base is same, right? Base is 2. Here also 2. This implies 2 raised to the power square into 3 minus 1 means 2. So it is 1. 2 equal to 2 raised to the power 5n. This implies 5n equal to 1. This implies n equal to 1 by 5. Here n is equal to 1 by 5. Same this formula only, right? So 7 raised to the power 5 minus 1 equal to, this side is, this can be reduced to 7 square. 7 square n. This base same. So 1 by 4. Power would be same. If the base is same, power would be same. So this implies 2n n equal to 1 by 4 into 2 equal to 1 by 8. Here n is 1 by 8. Done. Thank you.